Let's introduce the multi-protocol label switching or MPLS and see how it works. We can see here the network, the source network is 10.1.1.0 is going to communicate to the destination network 20.1.1.0 through router 1 and router 2, router 3. The three routers existing in the MPLS network, and router 1 is receiving network 20.1.1.0 from router 3. Router 3 is directly connected to this network and is going to advertise this network through the MPLS to router 1. So router 1 in its routing table has network 20.1.1.0 and the next hop of the network is router 3. Router 3 itself is going to be received from router 2. Router 3 sends its identity to router 2 and router 2 sends router 3 identity to router 1. So router 1 will record router 3 with a label or a number, and any packet dedicated to 20.1.1.0 will be sent to router 3 with a label. We have here the frame and packet. The frame and packet of the source 10.1.1.0. The frame and packet here is going to be received from the network, the source network 10, to be received at router 1. And router 1, before it sends the packet inside the MPLS network, it adds a label. It adds a label between the frame and the packet. This label represents router 3. It can now send all the packets with a label, and the label is inserted between the frame header and the packet header. In this slide, we can summarize what we've said in the last sketch or the last diagram. With a multi-protocol label switching MPLS, each destination is represented by a number known as label. Inside the MPLS network, each packet has a label based on its destination. In the last diagram, router 1 needs to send traffic to router 3, and router 3 is represented with a label, and all packets sent to router 3 is labeled with the specified number for router 3. MPLS header is added between the data link layer or the frame header and the network IP layer or the packet header. Of all packets flowing through the MPLS, any packet going to be traveled inside the MPLS network must be labeled, and it includes the MPLS label. Therefore, all routers in the MPLS network can forward packets to their destinations based on the label of the MPLS header. In this slide, we will introduce some MPLS terms that will be used through our course. We can see here in this network diagram the MPLS network or the service provider network. This network consists of a number of routers. These routers are known as MPLS routers: PE1, P1, P2, and P2. PE means provider edge router. The provider edge router is at the edge of the MPLS network, and it connects the customer sites to the MPLS network. The provider router or the P router, it connects the MPLS routers or the provider edge routers together in the network, and it's known as transit router as well. The customer side has a router that connects the customer side to the MPLS network, and this router is known as CE router or customer edge router. Let's summarize what we've said in the network diagram. The MPLS domain consists of a number of routers that run MPLS. Any number of routers, of course. Provider edge router or PE router, which is known as label edge router or LER. The provider edge router is a routing device that is capable of forwarding packets based on MPLS labels. Any labels from any traffic from the provider edge router to go inside the MPLS network must be labeled. The provider edge router resides at the edge of the MPLS network, and it connects the customer sites with IP non-MPLS interfaces. We don't have any MPLS between the provider edge and the customer site. The provider router or the P router, it's known as label switch router or LSR. The provider router is a routing device that is capable of forwarding packets based on MPLS labels. All of its interfaces are MPLS enabled, and it resides in the MPLS core network. The customer edge router or the CE router, it's a routing device located at the customer side, and it connects the customer network to the MPLS network with IP non-MPLS interfaces. All of its interfaces are not MPLS enabled. It's only IP interfaces.